All right, based on some things that I saw in some preliminary assignments today, I decided to take a minute and create another quick little video to sort of help some of you out when it comes to the graphing in the next 3 days. So there is a set pattern of how you go about this, and it's not just randomness that it's based on. So we start at 0 here, and 0 is always this position. You move up, you're going to be doing a lot of radian things, so I want you to get comfortable with that pi over 2. Remember that in the angle, in the degrees, not angle, in degrees, that's 90. As we get around here, we are at pi. When we get to the bottom here, we are at 3 pi over 2. And when you finish back here, you're back here again at 2 pi. Cosine to sine is the relationship of these answers and of these numbers. So when we graph the cosine curve, we are looking at the x values of the cosine curve. And when we're graphing the sine curve, we're looking at the y coordinates of these. So remember that the sine follows O, high O, low O, meaning O, there's your 0, that's the high point. At this quarter turn, we're back to 0. This quarter turn, you're at its lowest point, and back here, you're back to the O again. So a couple things I'm going to be particular about are a scale on the x-axis. You need to mark at least one, if not more, whether that's the first, the middle, the last, however you want to do that. Make sure something's marked. The other thing in the assignments turned in, people aren't marking this axis. This does make a difference that we know what the scale is here. For my sake, I'm going to make this one and this -1. So you need to mark at least one of those so we know what that is. So if I'm going to graph the sine curve, I'm going to follow this, and I'm going to graph it here. The O is here. This is my first quarter turn. So the O has to go to the high point of your graph. That's your max. My next quarter turn, which is the pi over here, is back to an O. The 3/4 turn, which is down here, so 3/4 of my circle, I'm at my low point. So that's the low. And then we come back to the O, the 0. Now, we use 0 in there for now, but as we go through and work through others, you're going to find out how that kind of moves. So this is what sine of theta looks like. So I'm going to show you quick here on the graph. I've loaded a part up on the graphing calculator for us to look at and see. We can work through this. Now, point S is set up so that it follows the height of point P. As I move, I'm just getting above 0. Notice this height is on its climb. As we go and work through 45 degrees, remember we learned the other day, 45 degrees, the height is the same on those as well as the x-axis. And you can see that point moving across the screen. So something that's kind of cool to do here, I'm going to run the trace, do a geometry trace on this, and I want to trace this point. So as I grab P, watch what starts to happen. There the S pops back in by the origin, and we move it through. As this curve begins to smooth out, what do you see? This is tracking. If you notice, P and S are staying the same height. So they're up here at this point, they're at its maximum. Then they come down. They're crossing the x-axis together there. That is the 180. They come back under. They are at its low point down here at -1 and come back. This is your sine curve. So when you trace the height of point P as it moves around the circle, that is going to be your sine curve as that works through. Okay, so you can see how that one kind of manipulates and maneuvers. So when we come down here to work on the cosine curve, I'm going to do that down here. We still have the same thing happening. This is still 0. This is pi over 2. This is pi. This is 3 pi over 2. So our cosine follows these curves. So the cosine is high, O, low, O, high. So at this stage, this is the highest place or the furthest in the positive direction this graph is going to be on the x-axis. So I'm going to make that 1 again. So the cosine starts at a high point. Wherever the maximum is, it has to begin there. Then it moves up here, and then it goes to its O. It's on the axis, that's 0. When you come over here, that's its low point. So the low point is now down here. I'll mark that as my high point. That's the low point. It returns back to the 0, the O value at 3 pi over 2. And here at 2 pi, we finish back at its high point. And so the cosine goes differently than the sine. Some of you paid no attention to cosine and sine in the graphs when you turned those in. You have to understand that those are going to be different. A cosine has to begin at a high point. And you're going to talk about, how do I begin at a high point of 2? What has to happen today? What would I see in the equation of cosine theta equals y if I'm going to start at 2? What if I'm going to start at 3? What will I start at -2? But in today's graphs, these zeros are all going to be and occur at the same place. When you're doing the sine function, you're going to see all 3 of those within that cycle. Now, another thing to point out that I want to mention is the cosine curve doesn't become a V where it keeps on going like a parabola. This curves down. Make sure you curve those graphs down when you finish. So I'm going to show you on this picture here as well what the cosine curve looked like. I'll have to forward ahead to this here, and we'll repeat the same process on this one. I got to find my S in here. Let me drag this up and around. Actually, it's C. Okay, so menu, trace. Oops, we got to go find trace. Trace, geometry trace. And we're going to do the same thing. This time we're going to trace point C. And you'll see the shape that point C does. Notice that P and C are not vertically the same height, but C is representing the movement of your horizontal point, how far you are from the x-axis. So P is the furthest left at -1, C is at its bottom. When I'm at 2 pi over 2, we're back to the x-axis, and it returns to its maximum at point P. So this curve is tracing, or this is tracing the x values, creates the cosine curve as we watch through that. So I just wanted to touch base on this and make sure every graph should have this basic high O, low O function for cosine and O high O function when you're graphing sine. You're going to have all of your x-intercepts at the same places for the sine function. Every cosine curve should touch the x-axis at those values here. So make sure you're particular about that when you go through and we finish these graphs up today.